Alright, so here we are on chapter 7 in Math 10-3. This is trigonometry of right triangles. The very first section, 7.1, is called the Pythagorean theorem, and it has to do with the relationship between the sides in a right-angled triangle. So, first of all, you need to have a right-angled triangle in order for this relationship to be true. The relationship says that the sides A and B, which we will call the legs of the right triangle, so A and B are the legs, and they have some relationship that relates them to the opposite side to the 90-degree angle, which is called C, the hypotenuse. So C is called the hypotenuse. Now, you probably remember from a previous course that the hypotenuse is the longest side of the triangle, and it's straight across from the 90 degrees. Now, the relationship that exists, which is very famous, is given as c squared equals a squared plus b squared. And all it says is that if you make a square of length a and add it to a square of length b, if you add them up, you will get the square of length c. That's what that looks like. If you took the square of size A and the square of size B, and if you added up those two areas, you would get the square of size C, which looks like that. So let's take a look at a famous example. Let's say that A was 3 and B was 4. So if you go 3 times 3, get the area of this square to be 9. 4 times 4, you get the area of this square to be 16. So that would look like this. 3 squared plus 4 squared, 9 plus 16, that is 25. So what they're saying here at the bottom of this equation is that the square of length c is equal to 25. So this is what we know to be true, so this is 25. I'll highlight all that for you. So everything highlighted is the area. I'll just fill it in so you can see that it's area. So 9 plus 16 is 25. So what we're trying to find out is the length of the hypotenuse, C. So if the square is 25, then you take the square root of both sides. After you square root, you get that C is 5. So that's the famous 3, 4, 5 right-angled triangle. Alright, so let's go to build your skills number 1 and let's see what they want us to do. It says label each side of the triangle below using a single lowercase letter corresponding to the opposite vertex. Okay, so X, Y, Z, Q, R, S, D, E, F, S, T, R. All they want you to do is, because this is a convention in geometry, that if the vertex is the capital letter, straight across is the lowercase letter. So the vertex is capital, straight across the side is lowercase. So that's just a convention in geometry so that everybody's on the same page in terms of, you know, what to expect with labeling. So similarly here, capital C, capital A, capital B, capital S, capital R, capital Q, capital W, capital Y, capital X, capital E, capital D, capital F. So same idea. Okay, now they're going to talk about the Pythagorean theorem, which I already mentioned. Here's the two big ideas. Here's the famous formula. If you look at this example, they got R and P are the legs, and Q is the hypotenuse. So it's always the long side alone on one side of the equation. So the long side's always by itself, and then the two short sides are on the other side. And you have to square and add for the legs, and the other side is just the square. Okay, here's question 3. Given the following diagram, use the lettering provided to state 3 Pythagorean relations that apply. Okay, so let's take a look at triangle DBC, which I'll highlight. There's DBC, and its relationship would have the hypotenuse A equal to the other two legs, Y and Z, squared and then added. So we're always using a right angle triangle, and the hypotenuse is always equal to the other two sides added up when you square everything. So for the second triangle in blue, we have triangle DBA, and the right angle is right here. So straight across, we'll have C square equals X square plus Z square. And now if I erase everything, I will highlight the large triangle now, triangle ABC. Now you have to imagine there's just one big triangle, triangle ABC, with the right angle down in the corner here. Straight across is D, so or no, D is a vertex, so the whole.
Staff, please excuse this interruption.
So across from the vertex B is this entire side, which is made up of X plus Y. So X plus Y is the entire hypotenuse, so we will square that. And the two legs that make up the purple triangle are A squared and C squared. Now, this is pretty complex in terms of our difficulty levels, so I wouldn't worry too much about this one in the box. In 10-3, you're rarely going to be getting more than one triangle. And of course, you'll usually have numbers, so it won't have all these letters. So if this seems confusing, then don't stress out too much. Make sure that you can do these two, though, for sure, the two in the circle. Okay, question 4 says a ladder L is placed against the side of a house H. So there's the ladder. It's placed against the side of a house H. And there is a distance D from the base. Draw a diagram and express the relationship that exists. So H goes from here to here, D goes from there to there, and L is the hypotenuse. So since L is the hypotenuse, L squared is equal to H squared plus D squared. And number 5 says rearrange the Pythagorean theorem to solve for x. and then solve for y. So this is to help us when we want to solve for the short side. Which is a leg. So if you want to solve for a leg, you'll have to subtract from both sides of the equation. So you get x squared left on the left, and z squared take away y squared on the right. And then to solve for x, we will have to cross multiply, or pardon me, we'll have to square root. And we get our solution x equal to the square root of z squared minus y squared. And you will have an identical solution for y. So let me just write the question if it was in terms of y. Okay, and I'll talk more about this in a few seconds when we're actually solving. So now they want us to actually solve. Okay, so let's start with number 6. So it's a two-triangle question. Doesn't happen that often. But what I would recommend if you have two triangles is I would try to highlight one triangle at a time. So I got one triangle in red there. I can identify that the hypotenuse is x because it's straight across the 90. And that 6.8 and 4.2 are the two legs. That means that 4.2 squared plus 6.8 squared is equal to x squared. And if I want to solve for this, I need to square root both sides. So if you have the calculator that I borrow out, you're going to want to use a bracket. Find the square button. And close the bracket. And this will solve for x. So on the calculator that I borrow, it's second function pi. That opens up the square root sign. Then I use a left bracket, 4.2. And then it's second function exp to get the square to come up. Then I close the bracket, and I got 7.99. So it's essentially 8. So I'll just round that up to 8. Now, since I have x, I can use that in the next triangle, which I'm highlighting here in purple. Now, this is no longer the hypotenuse. This is a leg. This is a leg, and 10.4 is the hypotenuse. And they're asking us to solve for y. So the relationship that exists in the purple triangle is 10.4 squared equals x squared, which we know is 8, plus y squared. So I need to subtract 8 squared on both sides. So I get 10.4 squared minus 8 squared equals y squared. And to solve this, square root, square root. And here I'm getting .6. Now, it's an important place to stop right here, just to give you a little study tip. Now, if you have a good calculator and you're pretty handy with it, you can solve your Pythagorean theorems very easily using your calculator. So if you're solving for the hypotenuse, and I'll just use the general form, c squared equals a squared plus b squared. If you're solving for the hypotenuse, all you have to do is type the square root button, then a bracket, and then a squared plus b squared, and then close the bracket. And that will calculate your c every time. Now if you're solving for a leg, and remember the leg can be either a or b, so it doesn't matter which one. Let's just say a. If you're trying to solve for a, and it's happened a couple times now, you'll notice there's a minus. So all you have to do is remember that it's square root, and then there's going to be a minus rather than a plus. Notice it's plus for the hype, and it'll be a minus for the leg. And it's the exact same pattern. You got a bracket, and all you got to think here is for subtraction, you would always put the big number first for subtraction to keep it positive. Big numbers go first in subtraction. And of course the big number would be the hypotenuse. So if you can always remember that solving for hype is plus and solving for a leg is minus, you should be okay. Big number goes first. And this is what it would look like in the calculator. And if you were to just write it down on paper, like a math teacher, all you would want is this: a squared plus b squared, and c squared take away b squared. But on the calculator, you make sure that you put in brackets like this, and this would go over the whole thing, which I'll just add just in case. Alright, so I would put this on my formula sheet and memorize it. Okay, a 40-foot ladder reaches 38 feet up a house. So we've already solved this problem earlier. So 40-foot ladder reaches up the side of a house 38. How far from the base is the foot of the ladder? Okay, so if you take a look at this question, what you want to do is identify, am I solving for a hypotenuse or a leg? So here it's an unknown leg. So I can skip to my cheat. It's not really a cheat, it's like a shortcut. Is I know that to solve for x, it'll have to be a subtraction. Put the big number first and we're squaring. You type this into your calculator with brackets, you'll get it every time. So I got a 40 square, take away a 38 square. And I got x is 12.5 after rounding. And my diagram is obviously not drawn very well. It looks longer than it actually is, so it's a bad drawing. Don't take the drawing to scale. So it's just a sketch. Alright, here we are at number 8. A field is 120 by 180 meters. So we know from previous chapters that that is a rectangle. So let me just sketch in a rectangle. So 120 and 180. Then it says, how much shorter is your route if you walk diagonally across the field rather than walking around the edge? So obviously from one point to the other, the shortest way to get there is a straight line. So we'll call the diagonal C. And the right angle's in the corner here, so we know that C is the hypotenuse. So to solve for that, and we know C is the long side, so I know it's going to be a plus. Just use 180 square and 120 square. Add them up, square root. If you type this into your calculator, it'll work every time. Use a bracket if you forgot. And I'm getting 216 after rounding. And we expect that number to be bigger than 180 and 120 because it's the hypotenuse. So it should be bigger. And then we answer the question, well, how much shorter is your route? Well, if you take the 180 and you take the 120, you add that up, you get 300. That's if you go the long route, take away the short route, 216, and it'll be 84 meters shorter if you take the diagonal. Now put a big star on question 8 because I know that there's a couple questions like 8 on your chapter test for trigonometry. So I think this number 1 means that we're at the practice your skills. So this is your homework. I would start here on number 1 and go all the way to the next page, which finishes. Only 5 questions for the homework for this section.